Hello everybody and welcome to my channel. Today let's take a look at another new feature that Swift 5.3 is giving us. Today I want to explore with you this new proposal that has been implemented on Swift 5.3, which expands the places where we can use the where clause to make it work with contextually generic declarations. Let's unpack all of this because it's quite nice and it will simplify a little bit our code. So let's first take a look at what where declarations are, how they work, because it's a little bit of an advanced topic in Swift. So let's first show an example of where do we find them. As usual, let's start with a type to exercise this. So in this case, we need to work with generics. So the simple way of doing this is just implementing a wrapper type that can contain a generic value. Now you can have different wrappers for different types, and this is where we can start adding functionality and start seeing how we can use where. A struct, even if it's generic, always can have a method that you can implement, but the tricky thing is that you don't know much about the generic value, so you cannot do a lot with it. This is basically the rule that follows the generics. The less that you know, the less that you can do with them. The more that you know, the more you can do with them. But of course, the more that you know, then you cannot write such as generic algorithms because you are specifying the type. So it's a balance that you need to analyze every time that you start adding constraints into a generic type. In this case, we can see how we can just make a wrapper type with the value 5, for example. Let's say that in this case it's an integer, and we can just use this and we see it printed. So that's fine. Now the power of Swift is that it allows us to extend the wrapper type and add, for example, another method. And now we can use this in the same way, hello, and we can do in extension. And there you go. This is something that if you have been using Swift for a while, you are pretty much used to do because it's one of the most powerful things of the language. But now let's make it a little bit more complicated. What if we want to add an extension, but only when the wrapper type, like this generic type T, conforms to specific protocol? Let's say, for example, that we want to be able to use equatable for some algorithm, and we need to conform it to that. So for that, you will make the extension again and make something that uses equatable. Here we just have an example of some code that uses equatable, and as the compiler tells us, we cannot use the equatable because T it's not equatable. So we have a generic type that doesn't conform to any protocol on this wrapper, but we want to only add this functionality to the types that are actually equatable. So here we can use where, and that's where we see it for the first time in this video, to actually say just add this function when T is equatable. And now this compiles and it should work. So to test this, let's make another wrapper that says by, and we can see if that's using equatable. We can test if that's equals to bye. Okay, and we see that it's false, it runs, so the compiler can give us this functionality because T is equatable. Now let's take a look at what we need to do if we want to keep adding functionality based on the conformance of the protocols of the generic type. So let's take a look at what happens if we want to, for example, T is comparable. Okay, so let's do a similar function like this, but for comparable. We are using a similar thing. We extend the wrapper again where T is comparable. And now we can use this, and instead we can say compare, and we can see which one is bigger than the other. Let's probably just use integers to make it simpler to understand. And there you go. But now, this is where the proposal helps a little bit. You can see that we are basically using the extension on the wrapper and constraining it to a specific type, and then we're adding functions that don't have any constraints on them. Which means that you have this boilerplate duplicated everywhere, where you need to extend the wrapper and extend the wrapper and extend the wrapper all the time, when the thing that you just want is to extend the wrapper once and add all the functions with the constraints on each function on the same extension. So let's take a look at what happens if we try to do this. So what we mean by that is that we should be able to get rid of this extension and move this here and move the comparable here and the equatable here. So now conceptually, when you read this, it makes complete sense because you're extending the wrapper, and then the function itself is the one that it's saying, okay, I'm only available when this happens, and this one has a completely different set of requirements that I'm only available when this happens. The extension itself doesn't do anything in this case. It just allows us to extend the type. It doesn't add any constraints. But as you can see here, where clause cannot be attached to a non-generic declaration. And that's a problem because this declaration, it's not generic itself, but we know we are in a generic context because wrapper, it's generic, and we know that t is the generic parameter that the wrapper has. So this should work. On Swift 5.3, this actually works. So let's take a look at that. So now we are on Swift 5.3, and if I try to run this, you see how it works. Again, the playgrounds don't play nice with the toolchains, so you still see these errors here, but you can ignore them. And just to prove that I'm lying, let's change the number here so the output changes. And there you go. This works on Swift 5.3. What is nicer is that you can even add the requirements, the where clause on the wrapper. You can combine both things, so you can actually have some reusable constraints across all the set of functions that you want to try. So for that, let's for example say that these extensions where we are adding equatable and comparable, they only apply when the type is hashable. So if we run this, everything works because a string it's both hashable and equatable, and a number it's both hashable and comparable. So all of this works as expected. Now let's try to see how these functions apply in some contexts and not in others. For example, if we make a non-hashable struct and we try to use this, so we make a wrapper and that wrapper has a non-hashable struct with 5, for example. If we do .syntax, we see we have the base and the extension, but we don't have the equatable or the compare functions here because the first thing that needs to happen is that t is hashable, and because t is not hashable, none of this one will work. So now we can see how this applies to every function inside. But now let's make a struct that it's equatable and hashable. So we can do equatable and hashable, and let's just, for the sake of simplicity, make this so the compiler knows that it can synthesize it automatically for us. And now we can try to use the same technique of trying to use all these functions. You can see here how we can access equatable because this type is both equatable and hashable, so it's hashable and equatable, so this one is available. But if we try to run the compare function, that's not gonna work because t it's not comparable. So it's hashable, so that works fine, but this function is not available because it's not comparable. What this means is that now you are free to write the code however you please. You can use the extensions where requirements, or you can use them on the functions. So it's quite easy to shape the code in the way you most prefer, which is super nice because it just unlocks the freedom that the compiler gives us on specifying certain things, certain aspects of our type on the type system, but without being too picky of how we do it, which is really nice because this all should make sense, and now finally it makes sense. So that's it for today. If you enjoyed and learned a little bit, please like the video, and if you want to know more about what's coming on Swift 5.3, please subscribe to the channel. Thank you very much for watching, and see you all next time.